This has been an interesting week. We just got done with the 20th annual Bakerman break here last weekend. This time last week I was in Cascade Locks, Oregon. Getting ready to throw the 20th annual BBI Bakerman break. And I'm not going to lie, I came home from that and I was just smoked. I didn't want to touch an amplifier, talk about radio, deal with people, deal with the phone, nothing. I just had enough. And the weeks preceding that were full of sadness and exhaustion, and I took almost a full week and almost refused to do anything out here, which I spent a lot of time playing with my RC car. I'm not gonna lie, I'm not even ashamed. My brain was fried and I needed a break. Well, it's Friday night. It's 12 a.m. For some reason, I went and laid down at like 7 o'clock this evening and woke up and I can't stand to lay down anymore. So I figure I'd come out here and look at something. So tonight's little project is this. Let's get the Wheel of Doom out here. We can do a full 360 panoramic and make it look somewhat professional. We'll get our Tech 9 Technologies here. I had to build me one of these because I got tired of trying to move around the towel. Yes, boys and girls, it is a Tokyo High Power. It is the mythical Auto-Tune 1.5 kW. Look at this. Little tiny wobble in the cabinet here, but you can't even see it. When they built this, they really sat down and they thought about it. They really did. This is serial number 140. Out of how many, we don't know. It's 220, 230, 12 amp. Or, well, 110, 115, 124, or 24 amp. Output impedance 50 ohms, of course. RF input, max power 100 watts. RF output 1000 watts. They call it the 1.5. The Tokyo High Power 1.5. Now, I vaguely remember this gentleman calling and talking with me about it. And I'm one of these people that this is a pretty rare bird, right, for bass unit. I've had its little smaller brother here, and I had one up for sale, and I've done a repair on one of these. And this guy was just at his wit's end on what he was going to do with this. He'd bought it new, and he had a lightning strike that took place right near his house. He said he had it take out computers, he had it take out TVs, he had it take out surround sound system. But he claims that his radio equipment is relatively untouched. Now he says, I turn this thing on and it don't do nothing. I'm like, okay. So I told him, I said, hey, I can't make any promises. I found with lightning strikes, it's like, sometimes it's better just to give up hope and just walk over and pop salute and slowly, summarily set the thing in the trash can. But this thing is so valuable that I couldn't give him that as a recommendation. The problem with lightning strikes is that high voltage just runs through everything. And it's like, we'll get one thing fixed and it'll run for a hot minute, and then bam, something else will break. And it's a never-ending deal until you replace like 99% of the components inside the device, whatever it is. I don't care what it is. Same thing with high voltage shock. Like, you know, let's say your amplifier isn't built the greatest in the world, and you have a high voltage arc that jumps over to the cabinet of your amp, and it runs through the ground system in your station, and it can whack out all kinds of stuff. Your receive, transmit section in your radio. I mean, high voltage is a killer, man. Killer. These things are pretty robust. And I just couldn't help myself. I just could not help myself. I had to say, yeah, let's put it up here on the healing bench and let's take a hot minute and let's take a look at it. So let's go ahead and let's take the outer skin off of this thing and let's see what we got going on underneath its skirt and see what she's got to offer the world underneath her. We'll take a quick look inside. Hopefully it's something simple. Never know until you try. I mean, this is organization on another level. I love working on these things and I love the inside of them. I mean, there's a lot of stuff in here that we're not going to be able to get replacement parts, like all the ICs that run the display. We might be able to track those down, but I mean, for the most part, we've got, you know, our 110 volt 220 that comes in. It goes through a safety interlock, which we bypassed with this little piece of phenolic. Goes through the, you know, it comes in, goes through our fuses, goes through the safety interlock, comes to this control board. Then over here we got our interface. The thing I like about this is one of the units with the MOSFETs in it. This amp goes everywhere. I mean, literally, it does everything except UHF and VHF. But the whole amp board, you can unplug it and take it out and work on it and then put it back in. And all your voltage test points are in place. The relay board is the filter board. This is your output filter board, by the way. It's in here loose, but I don't see anything. Like, I've crawled all over this, and I've currently got this thing set for 110 volts, and you do that by adjusting this switch on the bottom. And it was set for 220. I did not get a power cord with this amp, which is fine. It's no big deal. Believe me, I've got cords that'll plug right into this. Have faith. Not a problem. So I went ahead and I switched it over to 110 so I can turn it on. There's electronics in here that we don't want to bring up really slow, but in the same breath, being that I'm going into this blind, and literally the owner's description of what's taking place here is it just doesn't do, quote, anything, end quote. I just don't want to straight up whack it. You know, let's plug it in and flip the switch and see what burns up. I'm not that guy. I'm not that guy. So let's go over here and turn our on indicator on. Our variable tap transformer is on the on position. I'm just sitting here thinking here for a second. I'm all right. Let's, there's 35, 40 volts, 50 volts, 60 volts. We should have some kind of indicator at this point. So we got 110 volts going in from the Variac, and we've got no indicator. Now, I did the smart thing first, and I did a quick visual examination of the fuses. Visual. That sounds like we're talking about a hotel room. When I say visual inspection, I always think of the little maids that go in to do the rooms. If you think about it, when they're pushing their little cart around, you never see them changing out bedspreads or anything. It's like, nah, we biannually semi-visually inspect for stains or just always thought it was funny. You know, people, oh, you know, the bed sheets are fresh. No, they're not. The comforter gets changed out once a year on that damn thing, and if you're lucky, the sheets get changed once a week. Okay, we got good fuses. So the problem is up chain. Up chain from here. So we'll present it with some 110 voltage here, just direct. We got nothing. Nothing. All right, let's see where we're losing our 110 volt coming in. And let's go trace it down. See, I need a pointing tool. This will do. So our 110 volt comes through, the safety interlock comes out. Well, this is on the return leg, but the 110 volt comes out. Our fuse comes down to the board here, and it runs over, and it comes to this trace here. So I have these two modules out. I'm assuming that this is some kind of low voltage filtered supply. What it actually runs yet, don't know, haven't gotten that far. I'm just walking this through you as I've been sitting here looking at it. This is our 110 volt 220 control unit. This is a relay. There's a solid relay down in here. This is made by Omron, okay? So our 110 volt comes in, one of the hot legs, because it can be 110 or 220 depending on how the switch is set, comes in, hits this purple wire. This purple wire, in turn, I'll give it a little tug action here. It shows up over here, obviously, at our switch. Well, the next wire that comes out of that pole, and this is what trips this relay. There's this black return lead. This is what controls everything as far as 110 volt is concerned. Now, I haven't gotten that far to where I'm going to plug it in. I'm going to plug it in, and I got to probe for voltage from here back to here, and I can already tell you we got nothing. This in turn takes a tap off of here, right here. See that little guy? That's our return lead, and it comes here. So our primary 110 volt comes in, comes from here, bleep, comes in here, goes out here, goes into this supply. I'm assuming that's what this is. It's all sealed up, there's no screws. I'm gonna have to get my G.I. Joe mad soldering skills on here in a minute. And then in return, it comes back out and it flips this lead here. So that's what this is driving this. And this in turn, I think is, this power supply here is what trips everything to start running, if I'm not mistaken. Yeah, because this output signal that comes from this power supply here returns to this plug here, which in turn goes to this plug here, which goes over and drives this regulator unit, which in turn turns on the relay. So somewhere between here, here, and here, we have a breakdown. A breakdown, like a hardcore breakdown. All of these screws that hold this bar in, there's a body bar that goes across here. All of these screws are loose. I have a feeling somebody's already had their fingers in here at one point or another. Now, the guy did say that he had problems with it about 10 years ago, and at one point it quit doing anything. And he took it to a local ham guy that is now deceased. And the guy said, oh yeah, it was no big deal. I fixed it in 10 minutes. Give me $150, and it ran for 10 years. We don't know if the screws were not tightened when it was put back together. I don't know. And so I was like, I think somebody's fibbing to me because this whole board's been out before. So something is not allowing this to switch, which is not kicking on the voltage to the rest of the amplifier, i.e. the 110 volt fan, i.e. the transformer, i.e. our power supply. We're dead. We're dead from like the neck down. So PP no work. Let's take a good look at this power supply, since that is in turn what drives this. We shall return. Okay, so we are back and spent a little bit of time, like an hour or so, looking at this. This is like last month's project in my brain. I was going to look at this earlier this month. The previous segments you just watched were shot before the Texas trip and the Arizona trip and then a Mexico trip and the Las Vegas trip. So I'm home and I wanted to pick up where I left off, and I started chasing this thing. So this is our main switchboard. This is what controls everything in this amp. And there is no power causing this relay to activate. This is what turns on the amp, is this. Well, the switch over here runs on a 15 volt supply, which is this. It brings in a little bit of 110 volt from this leg into the purple wire. The purple wire flies forward, comes up here to the switch, comes out of the switch. This is our return leg, which is attached here, and this is our power supply. This is a 15 volt regulated supply, and primarily the only thing this does is drive this board. Well, I decided, because there's no 15 volt coming out, we've got these test points. These green things that look like resistors are actually inductors, and you'll see that this is the plug that comes off this end of the board, goes to this inductor, and we've got test points that are right here. Okay, so then the 15 volt comes out after it goes through the inductor, comes out, comes over here, and it powers this board. Well, there's no 15 volt DC coming out of this power supply, and if you start looking real close, you can see the burn marks on the board. So first thing is always you go and you check and you go to see if there's a fuse. Well, there's a fuse on this power supply. Rightly so, this thing is blown wide open. It is a 250 volt 2 amp fuse, and the fuse is popped open. Okay, blown fuse on power supply. Not the first time we've ever seen that. Well, we've got to ask ourselves, something further up the chain has decided to go open. And this is just the beginning of this nightmare. Remember, this thing is a victim of a lightning strike or a nearby lightning strike or something close to it. After I get this power supply fixed, we have absolutely no guarantee whatsoever. It's just like saying your girl's going to show up for dinner. You have no idea when you're dating if she's going to actually do it or not. Now, if we turn this thing on after we fix this power supply, what else is going to burn up? We don't know. So I start finger farting around in there, and there's this 1-to-1 inductor choke that sits like this, which covered up the burn mark. I checked the fuse. Well, that's kind of interesting. Pulled the fuse, and then I could see a little bit of scorch mark. I fiddly farted around with this inductor choke. All this is a couple Henry 1-to-1 input-output isolation. It's not even an isolation choke, it's just an inductor. The voltage comes in, goes out. So it comes in on this pin and it goes out. It comes in on this pin and goes out through this pin. Okay? Then it immediately dumps onto this rectifier. Well, the rectifier is wide open. Thank God that the rectifier then in turn dumps into, smartly, by the way, into this. There's a set of capacitors, disc capacitors. One here goes to ground, another one here that goes to ground, and then it goes through this isolation cap right here. So hopefully the problem stopped at this rectifier. That is a bridge rectifier. And what do I mean it's popped? Well, let's put this thing on diode check here. Let's back this out. And we'll go over here and we'll just simply say, okay, AC coming in on this line. Nothing. Dead short. Almost open. Almost open. Almost open. This thing is popped. And what I mean is popped, it's popped from the AC side to the AC voltage comes in on this side of the rectifier, and DC voltage is supposed to come out this side of the rectifier. It's a dead short. So it's backing up. It's shorting across. Now, I happen to have these fuses. By some miracle of God, I ended up acquiring some of these fuses. So I do have the fuses. The choke here decided to let go of King Mary and Queen Tut and let the smoke clean out of it. Okay, on both sides. There is no connection here to here, here to here, here to here, here to here. It doesn't work. There's no chokeage. And you can literally physically unwind the windings because the legs have been burned off. My first thought was, well, I'll just back a couple of the windings off and resolder the legs and we'll make this work. Did that. Backed a couple of the windings out, as you can see, and somewhere in the middle of this pubic hair wire, it's burned in the middle of the choke, in the middle of the transformer. So I've got to figure something else out. Getting parts for this thing are impossible. Now, I do have another option that's open to me. This is simply a couple amp, like maybe a 2 amp. I don't have any switchers. I used to keep a couple of them around. I might have used them on something. I could just replace this with a switcher, like a $15 plug-in switching module. I could. 110 volt come in, 15 volt DC come out, and it's regulated. That's what this chip does, and that's what this potentiometer does. It allows us to adjust our output voltage. So, I might have a prayer of finding an S1WB S6062 rectifier. Let's go see what the internet says. That was useful. This is a 600 volt 2 amp rectifier. I can use any kind of little rectifier I want. As long as it's got a 600 volt rating to it and it passes 2 amps, I can repair this portion of the signature here, this little widget. This, on the other hand, is a whole different story. I have a couple choices here. I can completely disassemble this thing, like as in take all the windings off it and rewrap it by hand, or I can simply just use some iron inductor chokes that are pre-wrapped. Be a little bit bigger, wouldn't be exactly the same part, but it'll get the job done. I'm going to go to my very small, very limited, pathetic joke of an existence, but I love them because they are here and they take care of me, and it's better than nothing. Electronics shop here in town, and we'll see what we can cook up. I doubt I'm going to be able to find this part. I doubt, but it's not life or death. This isn't hypercritical if I get this part. I do need to find a little bridge diode here in town. Bridge rectifier, I mean. We can get this thing to spit out 15 volts DC. We might be able to get this relay to close, and then we'll be able to go on to what the next problem is. We'll see. While I'm at it, I should probably pick up a little 110, 220 regulated switcher, and I might have to retrofit this. Because if that's all that's wrong with this thing, remember, we still can't get it to turn on. And I'm a little leery to just bypass this relay. Okay. Like I could sit here and close the connections on this relay and power up the rest of the amp, because I don't know what else this 15 volt power supply feeds. Now, in the block chain diagram here, it recognizes this power supply as DC sub power supply. But then when I go and I look at the block diagram on how the thing operates, remember I said very foolishly, I'm not going to need no schematics. Stupid people say stupid things, and I'm a dumb SOB. So, I was kind of fingly farting through this. Come on, where is it? So I can throw it up here on camera and we can all move on with our precious moments in our life. There is a engineer's block diagram that's in here that I want you guys to see. So here's the main block diagram I was talking about. So according to this, we have our AC line in. Now we have our fuse and our filter system. And then the power comes in and it goes to our sub power, which is the module that we're working on. The module in turn is powered by the switch, which comes back over here. So I need a pointing device. I mean, this is simplicity at its best. Okay, AC line in. Then from our fuses and our switch for 110 volt and 220, it splits and it goes off to our switch, which in turn runs our main force. But this switch here is our on-off switch for the power switch on the front. It switches this power supply, which in turn drives this switch here, and our also allows us to close the other side of the switch. So this switch and this switch are what control the AC that comes in and goes to the main power X transformer. Then that goes to the bridge rectifier. And as it clearly states up here, the main power supply feed is 50 volts DC power to the final PA stage. It is a non-regulated power supply consisting of the compact transformer used as an bridge dial rectifier, blah, 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 works like every other freaking amplifier on the face of the earth. Okay. This block diagram is not showing us that this is feeding any of the other subsystems. Apparently, this little power supply, all it does is create a switched 15 volts to run this board to run this. And then from here, everything gets closed. I'm telling you, this is simplicity, but a little bit of an over-engineering thing. Well, I'm going to take off. I'm going to go see if I can find us a rectifier. Okay, just need a DC or AC to DC rectifier circuit, bridge rectifier. 2 amp, 600 volt. I think I can handle that. And I got to recreate some kind of choke system as a filter. I think I can handle that too. Hopefully I can drum up the parts. Now, my little shop that we have here in town is nothing like what I've seen just in the last couple weeks. I'm telling you, when I was in Phoenix, I saw an electronic shop that would have not only every other part on the face of the earth in it, but it would have these exact parts in it. I don't have access to that unless I order the stuff and it shows up here through the mail. But for the simple sake of simplicity, we're going to replace the rectifier and we're going to replace the choke. If this in turn pops again, that tells me that this regulator is open. So I'm probably going to buy a couple of these. I mean, there's not a whole lot left. And like I said in the beginning of this video, lightning strike repairs are a pain in the ass. Hopefully that's all it effed up. Because if it effed off this, or it effed off this, or it screwed up something else down the line, we're going to have to start ordering parts. But for right now, I don't see this being too big of a deal, especially taking into account this filter cap isn't damaged. We hope. I'm ready to go now. So, I went down and was able to find this simple WO2G 504M, which is labeled as a 400 volt bridge. And then we got ourselves some 120U plus or minus 10% actual inductors to take place of this tiny little wire wand inductor and this little tiny bridge. So the pin orientation for the rectifiers a little bit different. This bridge here, it's got AC coming in on this side and the DC negative and the DC positive coming out on this side. So I had to get a little creative, had to move a couple legs, like here's my positive leg and here's my negative leg on this one. So I had to have the AC leg and the ground leg pass each other underneath the component. But we made it fit within the real estate that was needed here. Okay. We're going to run this up on 110. We have this set at 110, but we're not going to tie the DC output side to the rest of the amplifier. We're basically going to use just the pinouts, this plug here, and a variac controller input voltage. I just want to sit here and run up slow and kind of watch it, because I have a feeling that maybe something else downstream is a little bit effed off. According to this component, input is AC 100 through 230 volts. Output, or pardon me, 50 to 60 hertz, plus or minus 0.30 to 0.50 amps. Output is going to be 12 volt, 0.09 amps. And apparently this whole subassembly is made in China. So we got our voltmeter hooked up to the output side of this thing. And I want to see if this thing just smoothly turns on and runs up. And if not, where the smoke comes out of next. The variac is off. Not that I don't know what's going to happen here. I don't know what else. I know the voltage coming in, inductors, voltage coming out through the rectifier, that's good. It goes through a couple discs, then it goes through another transformer, then it goes through a voltage regulator. So it goes through a couple inductors, then the output goes across this electrolytic as a filter. There's a couple inductors, then through the voltage regulator, then the output circuit. So I don't really know for sure what is going to happen here, but we're going to run it up real slow. I'm not going to be too surprised if smoke comes out of this again, but this whole circuit's kind of silly to me. I was sitting here thinking about it today. I was like, man, this whole circuit is here because they didn't want to use a bigger switch, or just use, I don't understand why they didn't use just a 110 volt or 220 volt relay. Anywho, power's on. There we go. I'm just going to sit here and let this run for a minute. I will be shocked if this fixes our on-off issue, truthfully. It's a bleeder resistor that's getting hot. That's it. So technically, power supply is running again. If it whacked this simple circuitry, I'm very afraid to see what it whacked the rest of the way down the chain. Does that make any sense? And I have a feeling that this has been apart once or twice. So I want to go back. I'm going to pull the schematic and make sure I got the pinouts for this portion of the circuitry right. I know I got this plug right, but do I have these two plugs right? This is my question. This is the 12 volt input or output from here, shows up over here. And then that in turn modulates or runs the rest of this unit, which this is also a DC rectifier, and then this is a relay that turns the 110 or 220 volts onto the rest of the unit. So let's go ahead and let's kill this off. I'm going to wire this outside the case, and I want to double verify something here real quick. I think I'm ready to proceed. Pretty sure I got everything plugged in the way it's supposed to be. Like, really sure. I'm not testing any shorts. Let's change how this measures here real quick. Thermal mode only. I'm not seeing any shorts on this board. And that's the only thing I can tell that this unit feeds is this board. So, I mean, I got more parts. I bought a whole bunch more of these parts, and I got a bunch more of these fuses. So if we end up popping the supply, I'm not going to get too overly excited about it, because here we go. Oh, the fan for the freaking amp came on. Oh, that kicked on. Nothing's hot. I hope and pray that the lightning only took out this. Let me put this all the way back together, and then we'll see what happens next, because I dare not try to load this without the shielding on it, and I dare not try to load this without the heat sink and then its mounting board on it. So we soldered the enclosure back together, which everything fits everything fits pretty well. And now, I'm kind of putting a wiring harness back in here the way it was. Getting it so the case will close smoothly and not pinch off anything. I think that's right. It's about the way that was before I took it apart. Let's grab the hot air gun here real quick. Reheat up this heat shrink. Way overly elaborate, but it's okay. So let's make sure this is in the off position. Let's see what happens here. Yay. Okay. What is that showing me on the front? Why is the needle up so high? Volts. So we're looking at the PA voltage. Cool. ICOM, Yaesu, auto, Kenwood, manual. Antenna switch A to B, A, B, A, B. ICOM, Yaesu, 10 meters, of course. Oh no, that's 10 megs. Yaesu. Okay, so we'll watch our PA voltage here as it runs down. Okay, so he says it's just dead. It won't do anything. It doesn't even turn on. It's nothing. So we're already in a better place. We're in a way happier place. It turns on. Now, does it make power? Don't know. Is it going to key up? I don't know. The fan is a 24 volt fan. The big electrolytic inside of there is a 63 volt, 68,000 UF filter. This is our meter shunt that is right here for the final section. The FETs that are in the final end of this thing are relatively cheap. They're like 20 bucks. I mean, like, really cheap. Okay, so go antenna A. Standby ALC ICOM. Let's see if we can get it to make any kind of power here. What do you think? You think it's going to work? I don't know. Watt mode. Let's grab our ICOM 7300. It's this one. Plug this into the input. We're on antenna A. And I do believe that this is a manual key setup. So I had a gentleman over here the other day. Now, like, you can go in my house and eat off the floors. It's spotless in my house. But out here, it's like, because people won't stop sending me stuff, even though I'm not taking on work, I got no room for anything anymore. I'm completely overwhelmed and overloaded out here. It's hard to say no when the argument is on the other end, but you're the only one left working on anything. I would not say that's truthful, but let's flip this into operate. Oh, negative. Okay. Turn the radio on. So it's going to be a 160. Let's go to AM. AM. It's working. Oh, shnikes. Check this out. So running ICOM, roughly 160. It wants 160 here by that indicator light. This is a 1000 watt slug and peak here. Let's turn the amp into standby. So we're putting 10 or 11 watts in. Oh yeah? I'll be darned, it was just working. It did, it made like 400 watts of power just a second ago. There it is. Huh. It is making power, but I have no key mode. I'm going to call the customer. This is making power, ain't no doubt about it, but it's doing it in the wrong band and I can't manually adjust anything. So I'll be back. Give me a minute. Look over my shoulder here. So I just read the whole manual front to back, back to front. Called and talked to the customer. He says he was in 160 meters when whatever happened. It took out his printer, his computer, his modem, and a couple other things in his house. And for some reason whacked this. He uses a manual foot key. He does not use any of the fancy dancy controls. So I'm thinking, okay, whatever it was a huge power spike. Now he also told me that it did not take out any of his radio equipment, his other radio equipment. He's using like Palstar antenna tuner and so on. So everywhere in the manual it says you cannot change modes of operation like your bands. And I'm praying that, look, this is IC circuitry. This is outside my wheelhouse. Okay, a man's got to know his limitations in life. And sometimes it's not best that you always run up to the baseball bat with a baseball bat to the plate to go swing. You know, if it's something down here on this board, over my head, and I'm not even ashamed to say that. I will get lost down a menagerie. Now, what I want to see though is the foot pedal. Let's start with the basic. I said, okay, fine. Let's just stop. And before we let ourselves get overwhelmed and say, oh, we don't know, and give up, throw our hands up, this is a rare unicorn. I think we can all agree. So I thought, let's just start with the basics. And so I take my voltometer and I go back here to the back of the cabinet and I probe on the RCA connector, which is supposed to be hooked up to this top one that says send. That's what actually is your manual key of operation on this thing. So it showed me a dead short. And I'm like, is it dead shorted in the wire? Here is your RCA jack, but it runs all the way around. and it comes to this plug. Specifically, it comes to these ports. So, let's show you something. We're probed. Step on the pedal. Okay. So now watch what happens when I plug this into the board. Has an incoming signal that comes from the RCA jack, then the outgoing signal goes around and it goes back over to the actual relay control board over here. But let's go in here and we'll grab one of the grounds because that's common. Nothing, step on the pedal. Dead short all the time. So, where does this go? There is a short in here from this plug to, I'm assuming it's going to be one of these transistors that's here. I'm just looking at the way the traces are kind of routed, but I don't know. So it's constantly getting the signal of transmit. And it could just something be as simple as one of these transistors is effed off. So if that's the case, I mean, it's just a process of pulling this entire, unplugging all this menagerie of shit, pulling this board off, figuring out what the transistor is, changing that transistor out. Because the transistor could be shorted to ground. I gotta get the schematic out. But so I told us I'm not ready to give up. I don't want to give up. But if I go and I key or change the transmit receive and get that running, why? I don't understand why I can't change modes even in standby. You would think that in standby mode, when I take it out of operate, put it in standby, it should totally ignore this switch and allow me to change bands. Because once again, this is the back side of the band switch. It's pumps a signal out here, comes over to this board, and it says up. So then it in turn changes the signal that runs the LED indicator and then changes our relay pack back here. So I don't know. It's like I told him, I don't know if we're going to reach a point where it's like it's not any rudimentary stuff. Like it might be something effed off in the processor, right? I would hope not, because we've got a working PA section. We just have no way to change bands or to be able to control it being in receiver transmit. Oh, do I want to bite this off? Pain in the ass. All right. Let me think. Okay, so after referencing the block diagram here, everything loops back to the main control process, which is this little guy here. So I go over here and I look at the schematic block diagram on this, and I understand that this here is J5 connection. That is the, and I'm going down a rabbit hole because I'm trying to figure out which direction I should head. And if it's something simple, it's just like a little transistor or something, hey, I'm all about fixing it, because let's face it, this thing's already broke. I can't break it any worse, right? It doesn't hurt to try. But at some point, you got to know where to pull the cord, right? So it tells me that this is junction J5. Well, then I come over here to this diagram. In junction J5, we've got a resistor at 10K. There's a capacitor that couples to ground, then it runs off to the IC. I'm like, okay. So then I come over here on this. And let's see, we are talking about that pin, something smaller than this. That pin right there. Here, you know what? It's about as good as we're gonna get. And I think we should be considering ourselves lucky with this camera with this lens on it to get that. So we're talking about this pin right here. Well, this pin dives down and it comes underneath the board here, and it comes to a capacitor. Okay. So then it hops up and it comes through this piece of ferrite as a choke. Then it goes out and it comes along, let's see here. Comes along and hits this post, comes out, goes through this resistor, which drops to here, and then that goes through this 10K. Pardon me. Got lost. This 10K. Well, this 10K in turn shares reference to a bunch of other stuff. When I take this post, pardon me, and multimeter it to ground, I've got a dead short. Okay, it's like, not dead, it's like 11.5 ohms. But I can meter it on the other side of this resistor, and I got 10K going from that pin through that resistor is 10K. So that means the short's happening before this resistor. So then we back up. Down here is a little tiny trace. So going to resolve it. No, it's an LED light. Of course it's not going to resolve it. Needless to say, you can see the little tiny trace taken off, and it goes between that first and second transistor, and it comes off to the via that is right about right there. That via then in turn goes through the board, and it comes out here, and it takes off and it goes underneath the processor, and then it drops onto one of these legs on the processor unit. So it tells me that there's a problem inside of this processor. Some high voltage got in this thing and snuck by this cap. Now the reason I pulled this cap out, this little blue capacitor, I was like, aha! The cap is shorted. And what made me think the cap was shorted? It's got a freaking hole burning one side of it. And I went, oh, eureka, maybe another simple fix. No, not the case. So I pulled a cap out, still have the same amount of resistance, it's still shorted. And I mean freaking shorted, hard shorted. So then I pulled the part numbers for this thing off the little IC chip here, little processor chip. Mouser says these are an outdated, non-supported component. It's an 8-bit microcontroller. Expected lead time, 62 weeks, question mark. Yay. DigiKey, also the same thing. American Microchip. They show that they have 0 in stock. There's a cross for this, but it's not an exact cross. Octopart, which is just simply another Chinese Alibaba distributor. They say they have 2 in stock. Let's see. $13. Nope, pardon me, that's a lie. Back ordered for dispatch on 24/10 of 2022. So Octopart says that they have one. It says it's an 8-bit PCI microcontroller, PIC 18F, 40 megahertz clock processor, 128 kilobytes flash, 80 pin. Here's the problem. If I can find this chip, what did they flash the chip memory for? I don't know. I have the technology to be able to change this chip. I don't have the ability to write the software to the chip, I do believe. Unless the chip is controlled by some of these other EEPROMs that are around it. I don't know. But at this point, I know high voltage got in here and it whacked the shit out of this. And it's stuck in continuous transmit. So it's not a physical malfunction as far as the switches are concerned. So I hate to say it, this might be the end of this video. I gotta call the customer and see what he wants to do. It's a shame because the final section on this amplifier is in perfect condition and it makes power. It just doesn't understand what it's supposed to be doing because the chip here is effed off. I need a drink. I'll be back. Okay. Super clean, eh? Called him, told him what I figured out, and he has decided that he is not interested in repairing this. He's got full insurance coverage on this. He's going to go and have it submitted to his insurance, and I said, that's fine. I'll write you up an evaluation and estimated cost of repair. Replacement cost on this unit, initially, purchase value was $3,900. So therefore, the replacement cost of this component is going to be roughly $3,900 because, well, it's an all-band auto mode, go everywhere. And the shame is there's nothing out there to buy right now. There's nothing out there to buy right now. The supply chain's so messed up. So unfortunately, he says he doesn't care what happens with this. I'm going to put it all back together in one piece. I told him, I said, man, if we took and we broke this thing up and sold it for parts on eBay, you would probably be somebody's hero. Because I know there's a Tokyo High Power out there that's got this whole final section that's junk. And there's somebody out there that needs this bridge and probably this control and this face and the tin and the power supply. And it is 99.998% right. Okay? It's that last 0.2%. That little guy. Makes me sad. I don't even know why I poured this because I don't drink. So, we'll pour one out for the dead Tokyo High Power. On that note, I'm going to put this back together and I don't know what I'm going to do with it from here. It just makes me cringe inside. I mean, if somebody wanted to, they could create themselves a little adder control board and all you'd have to do is be able to drive these relays in the back. You have a fully functional amplifier, but as far as getting this thing back to working the way it was meant to be stock, it ain't happening today. It ain't happening today. So I respectfully take my hat off to you, Tokyo High Power. You've officially beat me down to the point where I got to call no glory. Gentlemen, I appreciate you all tuning in. Remember, you don't need no damn schematic. You don't need no damn schematic. Look, I am not taking on any new work right now. I'm completely covered up. I had a friend of mine, his name is Luke. Also, he came over here just yesterday and He's like, damn, dude, how do you get in and out of here? Look, you guys, you got to quit sending me stuff. Okay? Please stop. Please stop. I got no more room. I just don't have any more room. If you got a question, or if there's something that I can do to help in some way, give me a call other than working on your equipment. I just don't have any more room. And the people that are here, I've got guys that have been waiting almost 2 years just for me to look at their stuff. So please, I apologize, but I'm a one-man band trying to do everything I can. So I thank you all for tuning in. Unfortunately, we've hit the point where we can't go any further. So I finally had one kick my ass that I couldn't fix. And it comes down to a stupid surface mount component that is obsolete. I'll see you guys. Bye-bye. I'm a little bummed out about this. The availability of parts dictated a lot of what we were doing here. And this amplifier isn't mine. It's technically his. And it belongs to the insurance company if he's going to turn it over for a claim. So there's nothing really I can do to take it too far away from stock. But you and I both know, and when I mean you, I mean all of you guys, know that I've been sitting here thinking, there's a whole lot of other ways to make this amplifier work. With the PA section being intact, all the other circuitry is, the overprotect circuitry, the highest WR, wrong band, that kind of thing. With a box and about 8 switches, I think I could probably make this work. But I'm not allowed to go in there and do any of that to make any of that work until after the insurance company makes their decision. So there might be a part 2 to this. But then again, you lose all the cool wow factor of the high power. The automatic band selection, all that kind of stuff. We'd have to bypass that portion of the circuitry, and then we'd have to change the transmit receive side. That's not that big of a deal. The manual key operation, we can make that work pretty easy. So there might be a part 2. So we'll see. But I thought I'd put this out here for now, and I thought you guys might enjoy watching the struggle that we went through over here to figure out what had happened, but it is what it is. Gentlemen, I say thanks once again to all of you for being here, and we're on to the next one. We'll see you. Click, click.